All right. So, sometime back, Anand raised a really important question in the panel discussion is that how different is the journey of the cost optimization in case of startups, right? Because all of the talks that you have seen so far have been mostly big orgs, right? And the numbers were very large. But then cost is still a problem even in startups, right? So in this talk, I'll be talking about the journey of cost optimization for a startup as a client that we work with. So before we start and talk about the journey itself, I'd like to present some of the highlights of this journey. So over the period of around 3 months, we were able to reduce the total AWS monthly bill by 42%. Out of that, the production, as in the cloud cost for production environment, was brought down by around 35%, and for non-prod, we were able to achieve the optimization of around 50%. And while doing all of this work, as also mentioned by Ranga, that when you're making changes on production, you have to be very careful, right? So while making all of these changes in production, we made sure that there was zero impact on the business uptime. So all the business tasks were running as usual. All of this work was done by a single SRE over the period of 3 months, and the SRE was also responsible for the day-to-day support as well as any on-call and incidents, right? So who am I? I'm Sitaram. I work as a lead SRE at 120. 120 is a premium consulting company where we help growth stage companies to scale out their backend reliability functions. I'm a full stack engineer who turned to SRE. I come from a background where I've worked on front ends, back ends, and now settled on SRE because playing with incidents is fun. I love creating memes. You'll probably see them throughout the talk. Although I understand this topic is a little serious, but I'd also try to keep it engaging. I love barbecues. Today is a good weather. Would have been barbecuing, but this talk is fine. Okay. Also, love working on and solving challenging problems. So, before I explain the problem that we worked upon, I would like to give you some context. Then we'll talk about the problem itself. Then we'll go through the entire journey, and then followed by any questions if anybody of you has. So the client that we worked for this problem was they are a 7-year-old startup. They are into e-commerce where they have a no-code platform for Shopify. So, for example, if you're a Shopify store owner and you would like to build native mobile apps, let's say mobile and Android, you could just use their no-code platform where you can drag and drop things and then generate the Android and iOS apps within minutes. So the company saw good growth since the initial days. Basically new merchants were onboarded daily. There were a lot of new features developed over the years, which obviously caused a lot of architectural changes. In terms of scale, we were running on AWS for our batch and streaming workloads. In terms of services, we were primarily using compute, ECS, CloudWatch, OpenSearch, and Lambdas. Also, around talking about the numbers, there were around 150 plus EC2 machines and around 8 to 10 R5 2X large kind of RDS instances that we were running on. Now this sounds nice, right? Growth is nice. But then it also has its own challenges, okay? So now to share more context, basically the founding and the initial team did not have a infrastructure expertise in them. So basically what happened was all the infrastructure that was set up was kind of set up in a ad hoc manner. There was no automation, obviously. And then it led to issues such as, there was no IAM control, there was no tracking who has what access. So when we started working with this client, we had to do a lot of initial groundwork also, harden the security, also set up AWS best practices. But this talk particularly will focus on just the cost optimization part of it. Now, with this context setup, the problem was that because of the ad hoc nature, there was no visibility in the cost. Nobody knew what this particular service or this particular project was getting cost. The overall bill was around $25,000 US per month. And, at that point, the cost became a bottleneck for scaling the infrastructure. So, as even Sudhir mentioned that once you have the FinOps model where you have your requests for infrastructure changes go through scrutiny, right? So this is what would happen if you have a team, business team where you want to scale your infrastructure, you went with them for the request. This will happen, you'll just go round and round, right? So basically we started with setting up some goals for ourselves. So first goal was to reduce the existing infrastructure cost while making sure that there is no business impact and it does not affect any reliability and uptime. Next goal was, once we have reduced the cost, we should be able to govern it, we should be able to have visibility into it. And after that, once we have the visibility part, how do we make sure that we should be getting proactive alerts, right? Knowing before the cost increases itself. So for this, we'll basically talk about the journey now. We'll go through each of these points one by one, like starting with the identifying the cost centers, right? So before you start working on reducing those, you need to understand where your cost is going, right? So for that, identifying the cost itself is not the biggest problem here. I think most of us have attended previous talks where they have talked about using Cost Explorer, right? It's a fantastic tool. So using Cost Explorer is basically your friend, which gives you a lot of nice drill downs where you could drill down by services, then you can actually understand what happens within a service. In our case, when we started initially we basically started to focus on which top services are our highest cost components. We used basically the filters and group by dimensions to figure out which top services are contributing to it. Once we had the top services, then we started fixating on a service and then group by into the usage type so that we could understand within the service what was impacting for the cost itself. So once this activity was done, we were able to come up to this conclusion that the top contributing component was the compute, which was kind of expected. Then the next part was the RDS cost itself. Then the third component was a little interesting, but I think this has been also a theme with overall previous talks also, right? Data transfer charges. So since the client was also running in the single region, there was a little expectation about costs coming from data transfer. Another interesting thing that we found was the EC2 other category. So EC2 other category is basically which accumulates the cost for your snapshots, volumes, disks, and all of that. So it was quite interesting. Why are we accounting to 15% of the overall bill just for the EC2 other category? So once we had visibility in terms of what are the cost centers, so it's very natural for you to, once you have the cost, the leadership is going to ask you like, yeah, now how fast you can reduce that bill, right? Give it the immediate impact. So knowing that there were a lot of higher compute cost centers, like for example compute and RDS, we still decided to work on immediate impact items first, right? This is where how startups and big companies change, because leadership will obviously want a very immediate result from your side, right? But I feel it also helps, once you have started getting small wins, it helps to build your own momentum. It basically gives you more confidence on the work that you're doing. It basically assures you that you're in the right direction, right? Another thing is the higher cost impact center that I've shown, right? Compute and RDS. It's probably, you can still figure out how to reduce the cost, but making changes to those components takes more time. It basically needs more planning because it can incur a downtime. So having worked upon immediate impact items first will also buy us the time so that we can take more time and figure out and make more clear plans about how to avoid the downtimes when you're making bigger changes. So in our case, as I mentioned, right, the EC2 other category when we started out, so we basically use cost to figure out where are we spending on majority in the EC2 other category. So what we found out was, as being SREs, we obviously want to figure out where is the root cause. So we found out that the process that developers were using to provision infrastructure, they were just missing one small tick box where it says that delete on termination. This small thing basically accumulated a lot of number of EBS volumes which are unattached in our AWS account. So we just educated the developers about this process because there was no automation. This has to be done manually, so we had to educate them about the correct process. Once we did that, we also talked to them about which disks which are not probably needed, and then we were able to straight away delete them, and bam, we can just were able to reduce the AWS cost for that by around 85% within a day, right? So once we had the immediate impact that we could see, it got us more time to work on the higher impact centers. So working on higher impact centers, we basically followed a simple approach, and we think that we should treat cost as an engineering problem. Okay, so we should first measure, and then we should visualize, and we should then take an action. What do I mean by that? So in our resources, right, we should collect and measure the metrics that we are getting. So it could be different for each kind of resource. For example, compute, you could be focusing on finding out underutilization by focusing on CPU and memory. For let's say RDS, it could be your throughput, latency, replication, like all of that, right? So by measuring the metrics first, you get the necessary data, then which you can visualize it, and based on that, once you can figure out which resources are underutilized, then you can figure out the right action to take on those resources, right? Again, by being startup, we may not have access to a lot of fancy tools. For example, any observability platform or any other tool that even some of the previous fellow speakers have mentioned. So in our case, what we did was we simply wrote a bash script which would run on EC2 machine, because CloudWatch does not give you direct access to memory. We just wrote a simple bash script which would collect data and dump it in a CSV file, and wrote some automation tool which would collect those CSV file and then plot it in an Excel sheet. As simple as that, right? It did not incur any extra cost for us. It was very simple to do, but it basically gave us necessary data to take an action on it, right? So that's what I say. Basically, treat it as an engineering problem, measure, visualize, and then take action. So once we had that data, we basically started with compute first. In our case, once we had the memory data, we basically fixed it on a couple of instances which we again planned with developers, which did not being used fully. So for them, because those were part of ASGs, we were able to kind of roll them out using launch configuration types. So we kind of avoided the downtime in that case of scenario. But over the period of around 3 months, we were able to reduce the cost by 62 months. 2 months, we were able to reduce the cost by around 65%. Compute was still easy. RDS was interesting because, as I mentioned, right, we were using like R5 2x kind of instances. And even with those instances which are quite bulky, we were seeing a lot of utilization on those instances. So we could not simply figure out what is wrong with this instance, why it is getting utilized so high. So for that, what we realized is we probably need to figure out what is going underlying under the application where it is talking to the database. So for that, first we enabled slow logs. We tried to figure out why it is being utilized so high. And once we had enabled the slow logs, we were able to figure out that there were a lot of queries from the application side which were inefficient. They were not using indexes. They were using multiple joins, which were kind of heavy in terms of the cost. So with that, we basically created a plan with developers to kind of optimize the queries first. And once we had optimized the queries, we were able to get a reduced but stable metrics on the instances. And once we had those metrics, we were able to kind of now decide on what is the target instance type for the RDS we could downgrade to. So even for that, we used AWS's blue-green feature with RDS. So it allows you to kind of do the switching off or changing configuration of RDS instances with like no downtime. And once we did that, we were able to around achieve 25% of reduction over 2 months. So another interesting thing that even fellow speakers had introduced was one of the like very easy to do thing is basically use compute savings plan as well as reserve instance plan, right? So the thing with reduce reserve instance plan is that it is a commitment. So you basically commit that you will be paying this much. And because in our case, when we changed the instance type of almost all of our RDS instances, all of those reserve instance plan were going waste, right? But as the great Tata Sky says that, पूछने में क्या जाता है? So we still talked to AWS support team. Initially they resisted, but we still tried to make a case that, almost all of our reserve instance plans were getting wasted. So they did agree to, help us one time as a favor and, help us with a partially waiving of the RI plan, which kind of again helped us to reduce the cost further. Another thing that we figured out was in terms of CloudWatch log storage, we were getting kind of charged very high. And when we figured out the root cause problem was for a bunch of Lambda functions which were kind of running since the early days, for them log retention was never configured. So by simply educating developers to kind of like use log retention policy for Lambda functions, again we were able to save around 50% of the total cost by over 3 months. Now comes to the interesting part, right? Majority of the discussion so far has also been around data transfer cost, because it's kind of a hidden cost. It takes more efforts for you to figure out where does the data transfer cost happens. So in our case, if you look at this, the yellow bar, where before the optimization, in our AWS account, we were seeing around 2.8 terabytes of daily data transfer. I mean, we cross AZs, right? So this was again a surprise because this sounded ridiculous. So for us, what we did was we enabled VPC flow logs. By enabling VPC flow logs, we were able to like figure out from what IP to what IP we are having data transfer. Then we located which regions and which zones those IPs are located in, and we were able to figure out that for some of the batch workloads, which are basically VM based on EC2, and then which are talking to Elastic Case, they talk a lot, but they are all located in different AZs. So by simply grouping them and moving them into same AZs with multiple AZs, we were able to kind of reduce a lot of data transfer and kind of come back to as low as 116 GBs per day. Right? It was a huge saving in terms of data transfer. Apart from that, another thing we realized was that in terms of our private subnets, not all private subnets were provisioned a NAT gateway. So again, subnets which did not have a NAT gateway, they were traveling cross AZs to the other NAT gateway. So again, by creating a NAT gateway dedicated in each AZ also helped us saving the cross AZ data transfer. With these optimizations, we were able to save around 65% of cost on just the data transfer. So once we were able to work on all of these higher impact centers and bring the cost down to a level that was expected, the next part was about governance and visibility. So for this, we followed a straightforward process. The first part was actually tagging the infrastructure. Then for tagging, we had an initial internal proposal where we discussed on what kind of tags we want. So the first was environment tag, which would help us segregate between production and non-production costs. Second was service, because it was a microservices based architecture. We wanted to understand which service is costing how much. And third was a business related metric called project, because internally the organization used to name projects. So for example, if there was a R&D thing that was going on, if there is a let's say feature that was still rolling out but not for all customers, we actually use that label so that the business team could actually relate what the infrastructure cost is for a, let's say, experimental feature, right? So once we had fixated on the tags that we wanted to use, we used AWS's tag editor for bulk editing our tags. One cautionary tale with using AWS tag editor is that it's an absurd kind of a UI. So if there is a tag that is not present, it gets added, but if the tag is already there, its value will be overwritten. So just use that with carefully. Another thing with tags is that when you create tags, those tags are not automatically available in your cost calculation. So you have to basically update your AWS account settings to propagate the necessary tags that you want to follow in the cost explorer. So make sure to do that thing also. Once we had the tags available, next thing was to have be able to visualize the tags in the cost explorer. So after that, once we had the tags ready in all the existing infrastructure, how do we ensure that the future infrastructure that's created is also not deviating, or basically make sure that it has all the right tags? So for that, we used policy enforcement. We basically fixed it on these tags that has to be created. So anybody, because it was done by hand from the console, if anybody creates any resource which does not have those necessary tags, the request would be rejected. So once we had the necessary visibility, the next topic was to set up monitoring and alerts. So for this, once we had the total cost, we set up alerts on that. But apart from that, because we also had more granular visibility in using the tags, we also set up alerts by segregated tags, for example, production versus non-production cost. And for forecasting the cost, we use AWS budgets, which would tell us in advance when the cost would actually reach or cross the threshold in advance. So that's all about the journey. Then if I were to give about takeaways, so first is treat your cost optimization as an engineering problem. You have to measure the metrics, you are able to visualize and understand what is the differences, and then take the necessary action, making sure that you don't have a business downtime. Again, for compute related resources, make sure you are not underutilized. You can definitely use a lot of different AWS assistance tools, for example, recommendations, all of that. For data transfer, yes, the simple thing is you have to reduce the inter-region, inter-region cost. Next thing is bring the visibility into your infrastructure, tag, enforce them, and then be able to set up alerts so that you can have proactive monitoring on that. And as important thing is that you have to collaborate with the product engineering team, because there will be situations where you might not be aware of the underlying architecture, so that if you decide to take anything down, it might affect the product. So make sure you also collaborate with them. And Yeah. If you would like to read any such case studies, you can just go to the website or scan the QR. Open for any questions.
When you are speaking about bash script for collecting the metrics, is it a real-time metrics?
No, we basically just wanted to figure out which of the resources are underutilized. So for example, CloudWatch only tells you CPU, right? But once we were able to understand which CPUs are underutilized, we wanted to also know if the application or workloads which are running on those machines are not memory intensive. Because that way, CPU could be low, but memory would be actually utilized. So that way, we just set up memory monitoring, which would just dump the free memory every 1 minute into a CSV file and then collect it and visualize it.
So this is near to real time. What you mean to say?
No, we basically ran it over 2 days and then collect it into Excel sheet simply.
Okay.
Yeah. The whole purpose for just to understand the underutilization.